name my pyramid? By the base. Okay? So here's the question. A prism, right? Everybody agree? So it's a rectangular prism. Now I have a rectangular pyramid, right? So see how my sides are all triangles and I have my point like somebody said, and then it has a whatever base. So would you agree that this base right here and this base right here are basically the exact same?
Yeah.
Okay? So yesterday we looked at the volume of a prism. And our formula was what?
Base times height.
Base times height. Capital B times H, right? Where capital B was the base of mine. All right, so what do you think about the volume of the exact same base, but on a pyramid? Is it obviously more or less? Less. Now, how much less? So in other words, if I took this and filled it up with water, how many of these can I pour into this? Two, 4.
I think two.
Another 2. So let's try it out.
No, it's maybe 2. I think it's 3.
I think it's two.
But I want to say 4.
You want to say 4 now?
Lock in your answers.
It's not gonna be 4.
It's
No,
not.
there's no way it's four.
No way, it's two.
It's 3.
It's
No, it actually is two.
All right, so here's my prism.
Yeah.
Fill up my pyramid here.
This,
Yeah. The next Bill 9 will be.
that's no lie.
Spill.
You need some glasses and a little lab coat.
I want to see.
That was a precise pour right there.
All right,
So it's.
now what?
3, baby!
yeah, baby.
Go ahead.
Actually, might be 4.
Maybe 4 like goes with now.
Yeah, see, I thought it was 4 too, but it's 3.
Hey,
Landon, you said 4.
I said
is there
3.
gonna get another one in there?
Yeah.
Is it gonna run over?
No.
No.
Let's do it.
Depends on that pour, yeah.
Do it.
It's gonna be exact.
So,
What? That's trippy.
how much?
3.
So, if we said our, hang on, take those now. So, if this is 3 pyramids in one prism, okay? Now we switch over to a, what's this? A cylinder and a cone. And again, the only way that this possibly works is if my bases are exactly the same. So, does a cone do the same thing that a pyramid did to a prism?
Yes.
Yeah.
Is it the exact same difference?
Yes.
No, because it's
But it has like the.
Yes.
narrower.
So do you want to say that there's only 2 in this one that go into this one?
No.
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 I want to say like three.
It's more than 2?
I want to say like 3 or 4.
So you're saying 3 or 4?
It's more than two, but I don't know the answer.
All right.
I'm gonna say
Here we go.
4.
I don't know.
It is smaller, but it's the same.
It's not.
That was a bad one. Not even close to the top. There you go.
Big Ben. It's gonna be 7, 8. 3.
2 and 7/8.
It's gonna be 3. Yeah.
3 easy.
3.
What do you think now?
3
Is he gonna go over?
No.
Depends if the bartender here spills or not.
See?
Perfect, right? So, what conclusion can we make?
No matter how.
They're equal.
Take that out.
If they have the same base, and you fill them up with water, it always
If
takes.
they have the same base, it's always the same. Like, it's.
Okay, so if they have the same base, and we're talking about a pyramid, what is my relationship to what we had yesterday, which was V equals capital B times H, like you told me? So what was the difference with the pyramid? Was the pyramid smaller or bigger? Smaller, right? And how many times smaller?
3 times.
3 times. So how do you do that in math?
Or divide by 3.
So I'm going to take 1/3 capital B times H. Or, as you just said, capital B times H divided by 3. Those two equations are exactly the same. And we just proved that in our little experiment. Okay, so what's the difference now again? Capital B again is what? The area of the base. So again, what could my base possibly be? It could be a rectangle, right? What's the area of a rectangle?
Base times height.
Base times height. What else? We could have a triangle. What's my triangle?
Base times height divided by 2.
Okay. What's a trapezoid?
Base 1 plus
base
base 2
divided by
divided by
2
2
times
times
height.
height.
Perfect. Okay, so all of those could be my base. So on this quiz, when we're going to take this quiz, which will be tomorrow for you guys, and it says be specific for the B, that's what we're talking about. You got to make sure. Now here's the other thing that you got to be careful of. See how each one of them basically had a height? Those heights and this height are not the same. Okay, what is this height? Well, it was the height between bases, but now we only have one base, you told me, right? Because we switched to a pyramid. So what's the height? The height of the whole thing. So basically, if we brought back our other one that we just did, where's the height?
At the top.
Yeah, the top, at the point, right? So the height is my pencil, where it hits the base to the vertex of that pyramid. That's my height. So how do I know that it's a height for sure? Either case, there's going to be a right angle, a box. Right. But it's got to have that box on it. Okay? So remember, this H right here and these H's in this equation are totally different H's. Okay? Really important. So, what's the volume then of a cylinder? Well, what did we have for the volume? Oh, no, we did cylinder yesterday. What are we doing today? A cone, right?
Yes.
So, cylinder yesterday was V equals base times height again, but we simplified it yesterday into what? What is always the base of my cylinder? Yeah, but what is it? A circle. And what's the area of a circle?
So
Pi r squared. Okay? And what else did we have? A height. Okay? But now, what did we just prove in our experiment? How many cones? 3. So what do we need to do to this? Divide by 3. Awesome. 4 times by 1/3. So you can write it either way. It's just however your melon likes it. So I can multiply by 1/3 or divide by 3. Okay? Now, here's a question. Here's my cone, right? So when we're talking about this, they're going to give me a radius. Remember, a radius only goes halfway across. The diameter went all the way across. That was one thing that we tripped a couple of you on earlier. And here's my height right down the middle, right? And again, what do they need to show us? That box. So if they give us that this is 7 feet and my height is 12 feet, can we do the problem?
Yeah.
Yeah. So what are we going to do? What's r squared?
49.
7 squared or 49. What's my h?
12.
49 times 12 times pi divided by 3. Right? So I'm going to put it in here. Pi times r. R is 7 squared. Times h, which was my 12. And then divided by 3. Okay? And even though that we're dividing by 3, we're still talking about volume. So my label should be feet cubed in this problem. Make sense? Okay. Yesterday, I believe we talked about this. Let's see if you remember. What happens if I have a cone, but it's kind of off to the side?
Still leak.
It's what kind?
Oblique.
oblique, right? So here's the question. How do they show my height in an oblique one?
They drew it out, but just not line.
Yeah. So when they come over here and they give me my radius, then they're going to extend it a little bit more and put it on the outside. Okay? So here's the other question. If they tell me that my radius is 8 centimeters, do I include this little piece out here?
No.
I don't care about that piece, right? I just want to know where it makes a 90-degree angle. All right? So turn your book to page 570. And we'll look at a couple more examples, and then you can have the rest of the time to work.